Everyone, it's Mrs. Francis. I hope that you're doing well today. My video today is to help you with Molecule Lab C. The instructions are going to be pretty much the same as we had for Molecule B. However, our molecules are going to be just slightly more challenging. And so just reminding you, go ahead and do the naming. I would do this through the column for all of your molecules before you went across the rows. You've got the have, want, need, bond, and you will do this just like normal. I'm going to note here that we have worked with some polyatomic ions before, and when you have a negative charge, like a -2, you're going to add more electrons into the have. In this lab, we're going to have something where there's a +1, which means we have one less. So in the have, we're going to subtract. So I think that's something that you should be looking out for, and we'll note that here and again later on. So you're going to be drawing your Lewis dot structures and connecting the central atoms. Remember that some of our molecules will have more than one central atom. So if they have more than one central atom, you need to denote more than one molecular geometry. So that would be the shape name and the bond angle. And lastly, I have noticed a lot of students are forgetting to add in their lone pair electrons. That's both on the attached atoms and on the central atom. If there is a lone pair on the central atom, it will make a big, big difference in the overall shape. The lone pairs on the attached atoms, or the legs, are not as important, but still we want you to include those. Okay, so I'm going to go to the first page here, and I'm going to tell you for this one, O3, I want you to look up the name. It has a layman's name that it is most commonly known by. Here we've got a polyatomic ion. Don't forget, your -2 gets added into the have only, not into the want. SO2 should proceed normally. And then I want to point out these two molecules here. One is a polyatomic SO4 -2. And I want you to see how similar it is to SO4 here. But instead of having a -2, this SO4 gets its electrons from the hydrogen. So I want you to pay particular attention to how the shapes change. You will have 3 molecular geometries that you need to describe here, okay? 1 will be for sulfur and 2 will be oxygen. Here, you'll only have 1 molecular geometry. There's only 1 central atom, sulfur. Okay, at the bottom of the page, we have another polyatomic ion. You can just look up the name. Remember, polyatomic ions don't change their names. But I want to remind you that iodine is a halogen. And so halogens can only form 1 bond. And if you can only form 1 bond, or if an atom can only form 1 bond, it can never be the central atom, because a central atom requires 2 legs for 2 bonding areas. So our central atom will be 1 of these oxygens, and you'll have 1 molecular geometry that you need to describe here. So this one is a fun one to do. Okay, the one that I really want to spend a little bit of time on is C3H6. And so you have just recently learned how to do the naming on these. It's really important because the name is going to give you a clue about how to set this up. So remember that with this carbon, you're going to have 3 central atoms here, and you're going to spread them out on your paper here, okay? When you do the naming, I'll give you a hint that this one ends in -ene. And -ene is going to always have a double bond. So I remember that there are 2 E's and that reminds me, double bond. So with the two E's, double bond. Okay, and that's going to be important. So I made this structure with my molecule kit here, and so you can kind of get an idea. So you'll do the have, want, need, bond, and everything for this, but I want to show you how I'm going to look at the molecular geometry here. So if this is my carbon 1, I want you to see that I've got a double bond between carbon 1 and carbon 2. I could have easily done it the other way around, but organic chemists always start numbering from where the most, where the double bonds are if we have a chain like this. So this is my carbon 1, and it has 1, 2, 3, 4 bonds, but there are only 3 bonding areas. 1, 2, and this double bond counts as 1 bonding area. So this has 3 bonding areas and no lone pairs. So just to note that carbons, I'm going to say in general, never have lone pairs. And that's going to help us out. If you see a lone pair on your carbon, something's gone wrong here. So this carbon, carbon 1, will have 3 bonding areas and 0 lone pairs on it. So then I go to carbon 2. It also is attached to this double bond. I've got 1, 2, 3, and then 4. So 4 bonds makes 8 electrons, no lone pairs. But again, there are 3 bonding areas. One area is the double bond, the second a single, and the third also a single. So this also has the same molecular geometry as this does. And so if I cover up the rest of the molecule, you can see that trigonal planar shape. And then if I cover up the rest of the molecule here, I can see that trigonal planar shape. Finally, I get to the third carbon, and there's no double bond here. So I've got 1, 2, 3, and then 4 bonding areas. They all happen to be single bonds. And so there are no lone pairs. So I'm looking at something more like a tetrahedral. So I thought it would be important for you guys to see this because we were seeing some folks were having trouble with multiple central atoms, but that's what that looks like. Okay, 2 quick notes on the final 2 here. Chlorine is a halogen, so it is not the central. Hydrogen can also only form 1 bond. This is 1 bond as well. So these are not the central atoms, and unusually you have the last atom as a central atom. And then in this one, I had mentioned before, if you have a plus, that means you have 1 less electron. So you have to subtract this number out of the half. Okay, final thing that I want to talk to you about is this. We have learned about the naming systems for polyatomic ions. We've learned about the naming systems for hydrocarbons. We have learned about the naming systems for just our plain old binary compounds where we have nonmetals and nonmetals. We've even done the naming system for ionics where we have a cation and an anion. There is one other interesting situation where we have another naming system. Now, these naming systems are not here to cause confusion. They're here actually to help us figure out basically how to distinguish between one type of molecule from the next. And so I wanted to note to you that we have a naming system here for any molecule that is got a hydrogen at the beginning. And if you have a hydrogen at the beginning, this is going to be an acid. So we're going to eventually be talking about the naming system for that, but I'm going to just encourage you to maybe look this up. So if you type in H2SO4, you'll find out what the true name is. And if you type in HClO, you'll find out what the true name is. And so just a little challenge there to get the real names of those. All right, I hope my tips and tricks are going to help you guys as you work through Molecule Lab C. I want to say to everybody who's turning in their work, especially those of you who have been consistently pounding away at this, it is so much appreciated. All of us teachers are really proud of the hard work that you've done. Please keep it up. This will not be void. Your work is going to really pay off in many, many different ways. So thank you so much. If you have questions, please visit us during our office hours. Have a fantastic day. Bye-bye.